one object or two. It might depend on whether you have your glasses on. In structural biology, whether or not you can tell two different atoms are separate atoms will depend on the resolution of the structure. Resolution refers to how close together two objects can be, and you can still tell that it's separate objects. If I had a low resolution, this would all just kind of look like one thing, but if I had a high resolution, now I can actually tell that they're separate items. The separate things that we care about in structural biology are typically going to be atoms. The shorter the distance between those atoms where we can still tell they're separate atoms, the higher the resolution. So the lower the number of the resolution, the higher the resolution of the structure, the crispier the experimental data. And the scientists have to actually go and build that model into that data. Scientists use techniques like X-ray crystallography and cryo-EM to get experimental maps, which are kind of these meshy things that show you the broad outlines of where the atoms are, but scientists have to actually go in and model the actual position of each of the different atoms. And the crispier the data is, the easier it is to do this. It's kind of like if you're playing pin the tail on the donkey. If you're blindfolded, you've got no clue, and so it's kind of just a wild guess. Take the blindfold off. If you have really good vision, it's going to be easier to stick the tail on the donkey in the right place. But if you have poor vision, you're going to have a hard time. The poor vision is like having low resolution. So it would be a high number, meaning that you could only tell that the objects were separate if they were really far apart from one another. If you've got really great vision, well, here you're talking about high resolution. So you can very easily see where that donkey's tail should be, and so you can go and place the donkey's tail there. You can still place that tail on the donkey in the wrong spot, even if you have really great vision, but it's going to be a lot easier to do it correctly. Resolution is often reported in angstroms, 0.1 nanometer. High resolution corresponds to a lower number because it's saying that these can be really close together and we can still tell that they're different things. But if we had low resolution, we'd have a higher number, meaning that only if these objects were this far apart could we tell that they were different things. And if we had even lower resolution, we could only tell that they were separate if they were this far apart. If you have your blindfold off, but you have really bad eyesight, it's still better than having your blindfold on. And so even a low resolution structure can be really valuable. Scientists then have to go and place the model into the maps, and the crispier the maps are, the higher the resolution, the easier it is to do this. It doesn't guarantee that they do it correctly, so scientists have other data points that we can look to, such as the R-work and the R-free, to see if the scientists did a good job in actually modeling the structure to match that experimental data. The more complex a sample is, the harder it is to get a high resolution structure. There might be regions of a structure that you can't really see very well,